Hey, welcome. I've used that before. To another in this series of videos asking the simple question, why can't this be the truth? Um, what's wrong with this alternative idea to the, I'd argue, silly explanation provided by conventional physics? And yes, if I say it's silly, then I'm sort of insulting your intelligence because I'm basically saying you fell for it. It's just silly and stupid and you fell for it like some candid camera thing or something. So yes, you're going to be automatically defensive because I'm, making an accusation that you're a ignorant dupe. But anyway, yes, welcome to this draft physics video presentation. Anyway, so to the subject magnetism, basically, and just asking, there's lots of ways you could phrase the question. Conventional physics claims there's no such thing as a magnetic monopole. That is, there's no North Pole and South Pole of physics. It can only work in a magnet somehow. It doesn't exist separate. And I'd argue that it just doesn't make any sense. I mean, maybe Maxwell could say that, back in the 1800s, but somebody modern, we kind of know that magnets are made of magnets, essentially, that atoms are what are aligning up, that atoms are made of charged particles that are exactly the opposite in their character. And that sounds like a pole to me, right? Electron and proton, those sound like the magnetic monopoles. They have every feature of being such a thing, and yet it's somehow a bold statement to claim that the electron and the proton are the magnetic monopoles. If we could actually put a whole bunch of electrons together and then put a whole bunch of protons together in little balls, maybe people would get it, but obviously you can't do that because they're repulsive to each other, so you can't concentrate them. So that really won't work. But maybe, if that was physically possible, then maybe they would be able to figure it out, because you could make big giant monopoles and say, look, see, it's a magnet. If I put the two big giant charges next to each other, it's a magnet. Because it would be. Frankly. It would behave the same way as a magnet. If we could enlarge electrons and protons, it would be like a big giant little magnet. Big giant little magnet. But it really doesn't work with just charged things, because they don't radiate. They're just charged on the surface, like a balloon or something. You're not really creating a magnet, you're just creating a surface that behaves a little bit like it, so it's much weaker and won't give you the same effect. But anyway, I don't want to get too deep into that conversation. Just doing some context. So the other context is that they have two forces for which, gravity and magnetism, two of the really ones right in front of us. We see gravity, we see magnetism, we can play with them, we can feel them even. And yet they have no explanation for energy for either one of them. So gravity, they're just saying somehow bending space creates the motivation for things to move. It pushes them or pulls them or rolls them or whatever the hell it does. But it's some kind of mechanism for which we don't get to see any finger poke or any ball hit or any ether sucked, or however. We don't see anything. We don't see any machine, any mechanism that creates the energy, causes the stuff to move. And for magnetism, they use this idea of a virtual photon as some sort of force carrier, field creator. And this again goes sort of back to Maxwell, and what I would argue is complete confusion over what a field line is versus a line of force. And so they're both lines, but they're two different kinds of lines, and that difference makes all the difference in terms of understanding that this isn't a wave, and this isn't a ether vibration, and it isn't all this other crap that they make it into, and it could be really easily understood like that. When you understand that their mathematics really is saying that, in spite of what they think their math is saying, It's clearly saying it's a radial force, straight line force, in both cases, gravity and magnetism, and that's what creates the inverse square law that applies to the monopoles anyway, and to gravity. And it's just not that complicated. It's right there in front of them, and so again, I'm sort of insulting your intelligence by saying, gee, I don't know how you all got this so wrong when it's so easy to put the pieces together. You have to have a force. It doesn't make any sense to say stuff happens for no reason, that a virtual thing does something, or a bent magic happens. I've already explained you can't bend in 3 dimensions anyway. It's just not a good explanation. I mean, it's just missing the fundamental element of why. It's not an explanation of why it happens. It's saying nothing on the subject of why. It's pretending you have an answer by saying virtual photon if it feels like repelling, it repels. If it feels like attracting, it attracts. It creates some sort of, the virtual thing creates some sort of field thing, and the field thing does the attracting or repulsing. That's realistically the extent of their knowledge base. That's all they're going to give you as an explanation. It's just nothing. It's not an explanation of anything. And you should have been crying for better than that a long time ago. So again, I'm insulting your intelligence, but I'm sorry. I don't have a choice. We're really stupid to fall for this crap. To let these people, merely because they had the proper number of pens in their pocket and thick enough glasses, you let them sit there and fool you with just a silly story. One that's just on its face incomplete and insufficient. Wave particle duality. I mean, what? No, sorry. No, it can't be green red duality. It's just not fat thin duality. No, sorry, no sale. All right. So I have gone through this magnetism subject, so for the people who've watched before, I don't really want to be too redundant, so I do want to say something in a different way, and I'll attempt to do that. Alright, so this image is on my website, and it's sort of the basic point is that what a magnet should be thought of as is a filter. It's taking energy from the external universe. Again, I can point out the whole evolution of the photon, or the energy source, in the sense that there's all kinds of radiation right now hitting you that you couldn't detect. Even if I gave you a bunch of resistors and capacitors and transistors, you couldn't make a device that can detect a lot of the energy that's hitting you right now. And you're, hey, I don't even know it was there. It's going right through you, it's bouncing off of you, it's doing all kinds, heating you up, it's doing all kinds of stuff, but you're completely incapable of noticing it in any way. It took Hertz 7 years to figure out, even though he knew radio waves existed, it took him 7 years to figure out how to make some machine that could actually detect them. So anyway, so there's lots of this energy in the universe, and the simple argument is that there's 2 kinds of it, stuff that electrons reflect and stuff that protons reflect, and the inverse reaction happens when electron energy hits a proton. It's diverted by some 9 degrees, right hand rule kind of thing, perpendicular, radiated. Again, completely consistent with Maxwell's, equations, this perpendicular reaction. And through that simple mechanism, you increase and decrease pressure by causing constant reflections, and the inverse of all the energy leaking out in a direction that's not going to affect the 2 parties anymore. So any energy between them leaks out. In the opposite circumstance, the energy is trapped and continues to agitate the parties. And so there you have repulsion and you have attraction. You have a simple mechanism creating the 2. And all the magnet's really doing is just filtering that and showing you that I can segregate these 2 forces. I can make the electron force come out one end, I can make the proton force come out the other end, and another magnet will be able to feel that pressure difference, because if I put them pole to pole, I'll take a little pause just to avoid any noise problems. Yeah, alright, I'm back. So if you just understand the energy is already in the field, and all the magnet does is filter it, and through the process of filtering it basically capitalizes on the fact that the electrons hate each other, the protons hate each other, and the inverse exists in the sense that the opposites attract. The force is somehow not relevant when it's a proton and an electron, and it's not relevant because all the electron energy leaks out the proton, and all the proton energy leaks out the electron, and so nothing can get caught reflecting between them, and so there's nothing stopping them from moving into that lower pressure. And the inverse is true, as pointed out. Electron, electron, everything reflects. It's like they're a mirror surface to each other. So you can think of it as like a two-way mirror. You know, the electron energy always bounces off. The proton energy goes through the mirror. And, you know, to make it simpler. And you can just understand how obvious it would be that two opposite mirrors facing each other, all the energy leaks out, and you're just left with very little to stop them from being pushed by the external force into each other. You can really feel this when you take two magnets, you know, and you put them same pole against each other. You can, it feels just like pressure. It feels like pressure. And not that what it feels like is what it is like, but I'm just saying it's a piece of evidence that indicates, yes, you've got to come up with energy that somehow concentrates. The closer you bring them, the more repulsive they become, and that's exactly what this simple mechanism produces. So I think that's enough of that drawing. Go back to some key words again. That's not where I was and such. The simple argument is that there's really no facts that prevent electrons and protons from being understood to be the monopoles of magnetism. If I line up electron, proton, electron, proton, electron, proton in a substance, I will make it magnetic. It's just what's going to happen, because the electron and the proton are creating the dipole. They are the monopoles. It's just obvious. So magnets can be reasonably understood to be filters of energy, not sources of energy. So the word energy can be understood as this stuff moving the speed of light. It's a force, and when it's at a certain frequency, we can detect it with instruments. When it's not at a frequency, it's a little tougher. Certainly magnets can detect when it's been polarized. That is, when you're shooting out more of the electron stuff than the proton stuff in any field you create. Well, a magnet will detect that. But without a magnet, it seems invisible again. And an obvious one that's invisible is gravity. You know, moving stuff. We can't detect the stuff that's actually pushing the, you know, the stuff that's actually moving it. We can't detect it except this way. This is, you know, it seems a really good experiment for detecting. It's showing you what the force is doing, but we really can't see the force. we can't make it visible like you can make light in a laser beam visible by making it hit little particles and shoot reflections off, and you can know it's there. We can't really know this was there. I suppose it might be true for photons too. If we weren't capable of creating some thing for the photons to reflect off of, we'd be in rough shape in terms of recognizing the existence of even photons. And as I've stated in previous videos, we already know that we only detect a certain kind of photon in a very limited range of the electromagnetic spectrum of possible frequencies, and that we need a certain amount of that stuff to be able to see it either. So there are weaker rays, shorter rays, that we don't detect. They're there. Physically we can know they're there by effects like movement and energy and heat, but we can't. you know, separate one from the other. We can't know they're there personally. Can't shake their hand, so to speak. Alright, why do atoms and magnets move towards or away from each other? So the same question could be asked in gravity. Why do the little bits inside of something moved by gravity, why are they moving? What's doing it? They're electrons and protons. We know that's what the atoms are basically made out of, and the neutron is a composite particle, decays into electrons and protons. So we know these two polar objects, these two monopoles, are the substance of an atom. And you can sort of understand if the atom's got a certain configuration that from different perspectives it could look like different things. From one perspective it could look like a positive, from another perspective it could look like a negative, and from another perspective it looked like a dipole, which is a mixture of both and therefore a neutral charge. And so when we call something like the neutron a neutron, doesn't mean it's neutral, it means it's not either positive or negative. It means it has just as much positive as it has negative. So it's not really a neutron. It's neutral for a reason, and the reason doesn't mean it has an absence of charge. It just means it has a balance of charge. So anything that would have a balance of charge would look neutral, just like the planet Earth. All the charges are lined up kind of randomly, you know, simulating a randomness. And therefore you have just as much exposure to the proton side as you do the electron side, and therefore you don't see anything that looks substantially, yes, it has a magnetic field, but I'm just saying substantially most of the matter isn't making magnetism, isn't filtering, isn't causing any polar effect. So we really don't see it because it's mixed. That's not that there's no charge, it's just that for every positive charge there's some negative charge, and therefore we're not going to perceive an imbalance, and therefore we're not going to call it electron or proton. So anyway, it is that simple. I mean, I think that was pretty simple. Anyway, so it pulls them and pushes them. So again, you always have to ask the question. The little bits move for a reason. They are the universe. So this is another, you know, goes to other subjects, but realistically I could make a whole subject out of the just asking the question, what universe is the universe? Is the big universe the universe? Is this place that we're living the universe? Or is the real universe that little bitty stuff, and that's the only universe? We're just emergent things that happen in that little universe. It's not the other way around. The rules of the big universe aren't the rules. The rules are in the small universe. They're doing all the action. And if something moves, like the Earth towards the Sun, it moves because every single electron and proton has to be moved towards the Sun. I mean, that's not saying that. I mean, you know, it should be a statement that everybody kind of heard somewhere before. And yet, surprisingly, it's not said anywhere. You won't find it in the textbooks. Anyway. So why? The answer is reflection and diversion. As I pointed out, I've drawn it lots of times. You know, one force is ejected benignly, and the other force reflects. So through the process of just reflecting energy or passing it, you create two kinds of pressure, high and low, and you just place high and low pressures in different locations and things will move in and away. And that's why the little bits move, is because they're caught next to each other and they're reflecting energy back and forth to each other, and there's less energy on the outside than there is between them, and they move apart and vice versa. Very simple. Alright, so it feels like pressure because it is pressure. So that's kind of an obvious statement. Alright, so I guess we'll do some drawing to try to reinforce these basic simple points, but what's the evidence? Again, where? But none of Maxwell's equations that are inconsistent with any of this, because they're basically talking, well, I'll draw that part. And, you know, people have this perception that somehow waves are in the math. It really isn't in the math. Frequencies in the math. And again, they sort of cheated the words, velocity and wavelength, in the sense that they've now combined those two concepts because there's a relationship in how atoms function, where frequency matters, and so, but they're not the same thing, and so taking those mistakes out, if you just eliminate the mistakes where they're using the same word to describe two fundamentally different things, well, they're fundamentally different and have something connecting them, just one thing. And therefore they're just saying that's an excuse to call them the same thing. It's like you could say men and women both have feet and hands, therefore they're the same thing, when no, we know it's almost like they're complete opposites, because they have one property that's so substantially different. And the same is true in this argument, is the one property protons and electrons have in difference is all the difference. It doesn't matter what they have in common, because they have something not in common that is dramatically not in common. That is male and female, that is plus and minus, that is black and white, that is something versus nothing. Again, this sort of a starting point is even understanding that conceptually this is how you do physics. Physics is about something's happening in a field of nothing. So there is nothing, and there's somethings in it, and we're just describing the somethings and attempting to describe why they move and interact. That's physics. There's not something in something. The white space is nothing. That's the alternative to being a something. Anyway, all right. It's almost like the argument is there's nothing. So you could say still and moving, and you could say those are two states. But if you go to this small universe thing, you're going to sort of be stuck with the idea that nothing is really still. You just have the illusion of still, kind of like a school of fish. A school of fish can look like it's not going anywhere, but obviously the fish aren't just sitting there going nowhere. They're constantly moving to create the illusion that the thing isn't moving. So you could argue there is no still in the universe. It's just collections of balance where you've taken movement this way and movement that way and movement this way and movement that way and movement this way and movement this way in the 3 dimensions, and you've balanced it. So there's as much right as there is left, and as much up as there is down, and as much forward as there is back. But it's just an illusion, because the element of the universe doesn't do still. The something, that is the elemental something, doesn't just sit somewhere. But anyway, that's almost a separate subject. So I will be back very, very soon for you anyway. Alright, should be back. So we'll start with the simple drawing of the mechanism and keep it semi-brief. So the electron and the proton, and then you could imagine another electron, say right over here. And you're just basically trying to say, look, there's force coming from the universe, and all I'm telling you to believe is that the same as the cosmic background radiation, except there's more of it, little tiny rays of it, rays too short, broken, not enough to move electrons sufficiently to create electricity, and so therefore we don't really have a way of detecting it. Unless we can turn a force into something like electricity, we really can't see the elemental force unless we get it to move electrons enough to see their movement, or to cause a cascade, or a nuclear reaction. It's almost like if we were aliens and all we could see is nuclear bombs going off, because they created a chain reaction and enough energy for us to see them, and all other energy was invisible. Lots of ways to understand it. So there's 2 kinds of force in the universe, and there's 2 kinds of elemental matter, electrons and protons, and whatever we want to call this, electron force, proton force. And the simple argument is this force is always bombarding things, and especially when they're starting to get interacting with each other, the force changes from something that's completely randomized to something that becomes segregated and dominated by one kind of force. So the idea would be is that electron force would leave electrons, and proton force that went into an electron would likewise leave the electron in some other direction than that direction. Now clearly, if the more players you have, the more these turns, these diversions end up being something that'll move something else. So one thing moving will cause something else to move. And the other mechanism is just the repulsive force created, where if any blue energy gets, any electron energy gets trapped between electrons, as the electrons get closer and closer, the frequency increases, the intensity increases, because the little force bits always have the same momentum. So all you're really doing is counting how many times they hit something, and that's what we receive as something called energy. So the further apart they would be, the less energy there would be between them. The closer together, the more energy. Exactly how they function. Just nothing surprising. Now, if there was another proton here, it would be doing the same thing as the electron. All the proton energy would reflect, and that would create what is called the strong force in nuclear physics, because they think it has to be a strong force that keeps protons together, because they'd have to overcome this repulsion. But the trick is the neutron is basically an electron and a proton, so it's doing exactly what electrons and protons will do, and that is it's removing pressure. So if you put it, I should have drawn it that way. I'll just put another electron over here and you get the idea that these two electrons are supposed to be repulsive. And they would be if this proton wasn't in between them, because you can sort of understand that the proton would let all the energy that would have reflected between them escape, and therefore the two electrons can end up much closer to each other. Well, the same thing happens to protons when you mix them with neutrons. When you mix protons with neutrons, you're basically just saying this is your neutron, this and this, and you're just going to add another proton. And you can just understand that the other proton, I'll put it over here. Okay, let's ignore this relationship and just understand that, well, I really can't do it without putting them linearly. So just understand that if there was an electron between these two protons, you can understand that the reflective energy would leak out, and therefore the two protons could be much closer to each other, but they're not overcoming a force, they're diverting a force. So it's not a strong force, it's actually a very weak, low pressure that's created between them. So it just converts what would be a repulsive force into an attractive force by having the opposite thing in the picture. So anyway, that's the basics of the axioms of function. I'm just telling you that's, if you use these simple rules, two kinds of force, two kinds of matter bit, polarized in the sense that they have distinctly opposite effects on each other, you can explain it all. It's not complicated at all. It creates all you need to create repulsion and attraction, and to create high and low pressure. Alright, so let's understand, just in case for any of the people who just have some sort of whatever Maxwell obsession, when Maxwell drew charge, a plus charge or a minus charge, doesn't matter. The idea of representing the field strength, okay, was first to create lines of force, and these are the lines of force. So it was always illustrated, a charge, as a radial mechanism. And what Maxwell was pointing out is that this, this divergence over distance, these lines will diverge. They're close together at the very center of its gravity, so to speak. These lines converge, okay, and they get further and further apart as they go further and further out, and because they're doing that in 3 dimensions, it creates a square, and that becomes the inverse square law. Almost a cube. I guess if there's a line missing somewhere. Well, this line need to be longer, and then this one, that would be better, but it doesn't really matter. But that's the inverse square law right there. And so that's why there's the divided by r squared or r cubed. Now in the case of magnetism, because it's a dipole, it becomes an r cubed field, because the pollution of the red energy into the blue. Okay, so that's what you have to understand by it. What happens in a dipole is that there's places where these two are starting to mix. So at this end, you might say this magnet is an electron, and at this end you might say it's a proton. But here in the middle, it starts to get fuzzy, and that's where you get the divided by r to the third, because the force gets very weak the further away you get. The further away you get less polarity. So you can see it's a magnet when you're close, but the further away you get, it gets to look like there isn't a magnet there anymore. There's no polarity, there's just a neutral charge. So up close you can tell top from bottom, but from a distance it just sort of blends into one color. It ends up just turning whatever, green, purple. So you can't see the blue and you can't see the red, you just see the violet. And then you can have an over R in the case of when you segregate this electron or you segregate this proton, and then the charge becomes really strong because it's all just one, and the effect is very strong. Alright, so I think I'll redraw this. Yeah, these pens are just not terribly reliable, so I'll try to make sure they draw more opaquely. So let's go back to the lines of force and make a point here. So what they call, these are the lines of force, but what they call, they don't necessarily use the word, well, they say field lines. So when they say field lines, they're talking about there's a place where this distance between these lines is the same, and so you could draw that shape. And depending on the shape of whatever object has charge, like the electron is obviously, it's a point charge, so it's pretty consistent, but obviously big objects can be funny shaped, and so these lines, okay, will have different, this line will be longer than, say, this line, and so this shape of where the charge is the same would change. And obviously if I add a dipole, then you're trying to mix the two and say, well, where's the neutral points and where's the strong charge points? And so you could get like very close to both charges, and then the lines would be, they get further apart as you get near the charge, and then like this, and the lines would be different than this proportional line because you're mixing the two colors again. So when you mix the colors, the lines aren't as perfect, but this is what they call a field line, I guess, this line, and it's completely arbitrary. I mean, it just depends on where I decide the strength is. So say the strength is the strength of the field is a 10 here, and then it's like a 5 here, and it's a 3 here, and a 1, and then it's getting really, really weak as it goes further out. And so I could just say, where is the pressure 3? And then I could draw a line where 3 pressure is, and that would be the line you get. So when they draw magnets, people have this idea that there's these lines of force. Make the eraser magnetic. I don't know whether that's necessary or not, but anyway, I guess I could just leave it here. Yeah. So the traditional magnet, they draw it as having these lines, and those are the lines that they're not real. They're they're just an emergent property. They're something you can play with as an idea, but they don't really mean anything. So they have this idea that there's a flow of energy going around the magnet that comes in, and so it's moving around here and all this stuff, and that's not what the drawings represent. The arrows are just here because there is a difference in terms of polarity. When you convert this into electricity, the flow of electrons in a wire, for example, it matters which end is north and south, and that's why these arrows are here, but they're just telling you how it's going to affect atoms in a conductor when this dipole is moved. But it has nothing to do with any energy moving these paths, and this path is completely not a standard path. Depending on what I'm using to measure the strength of the field at different locations, I'll get a different alignment. So when you dump iron filings, you'll get an alignment. Now, if I dump the iron filings in a fluid, all these little iron filings will just line up as radial lines on the magnet. And that's all you'll get. And the key thing to recognize is these filings would all line up opposite the polarity of this magnet. That is, all the filings are lining up this way, red to blue, and the compass needles, and they're creating a magnet that's essentially the opposite magnet. They're creating a big magnet out here, a line of magnetism, and those magnets are the opposite of the one that caused them, and they'll all repel each other. So that's why the lines don't intersect. That's why they don't blend into each other. That's why they remain separate lines of force. But they're really not representing anything but the pressure at these locations. And in the case of the iron filings, it's sort of deceptive because you're actually creating magnets that are repelling each other. So these are really fake lines. But anyway, so there is no, these lines are, these are a made up kind of thing. They don't represent anything terribly real. The real lines are these lines. These are the lines that the math tell you exist. These are the pressure lines, and the two pressures just have a, in the mathematics, this is a positive pressure, this is a negative pressure, and that's all you're really talking about is how much of these lines do you have in a location. So I'm over here, how much of this stuff, negative stuff, is hitting me versus how much of this positive stuff, and I do a little bit of math and I can figure out what direction this thing will move if it's a positive, and how it'll move if it's a negative, and all I'm really adding up is how much blue stuff is hitting it, how much red stuff is hitting it. That's all I'm really doing, and then I'm saying what charge is it. If it's red, then it's going to be attracted. If the net effect is blue, then it's going to be attracted. If the net effect is red, then it's going to be repelled. And that's all the math represents. As you can see, there's no waves in here anywhere. There's rays of force. Lines of force, rays of force. No waves anywhere in here. Now if I jiggle this magnet, okay, now these force lines, these locations will change. If I jiggle this magnet, I'm going to change. I could change this field by tipping this magnet this way. I could change this from positive to negative to positive to negative to positive to negative. I can create a frequency. Still wouldn't call it a wave, but that's what's really happening, is that I'm fluctuating the field on and off. In this location, I'm converting it from I'm attracted, I'm repelled, I'm attracted, I'm repelled, I'm attracted, I'm repelled. I can cause this charge to move like it was waving. But it's not waving, it's just moving up and down. Okay, there's no medium, there's no waves, there's no other field to affect. But obviously if there was another charge over here, another proton, and I move this proton in and out, back and forth, I'm going to change what field's hitting this one. And that's going to make him move this way and this way. So I have this motion here, and I can have this motion here, and there could be an electron over here that's bound by another, pushed away by another electrons over here, and he's sort of in tension, and then I'm moving this thing, and then this is going to move this one, and then that'll move this electron, and that'll move this electron. So it's transferred, the effect, but it's all being transferred by straight line force, by little bits moving in straight lines. And that's the explanation. And the story you're told in school is just a story. And again, it's just such an incomplete story. None of this was explained to you. There was no explanation for why magnets move together. No explanation for what creates the pressure difference. If they even said the word pressure, they didn't show you what the pressure is made out of, why it happens, what motivates any of this stuff. But this is what the math says. This is how they understood the force as a straight line force. That part's accurate. Somehow, again, because they use the same words for stuff, you know, lines of force versus field lines, you know, because they use the same kind of words, it gets confused that somehow these lines are the lines, when no, these are the lines. These are the ones creating the essence, the foundations of the magnetic math. The math that tells you what the strength will be somewhere, all is based on this stuff moving in straight lines in vectors. So that really should be enough. Just to say there's nothing I know of. That's a clear, honest statement. I know of no experiment, no fact, no anything that demonstrates how this couldn't be the right answer. You know, beyond the fact that we don't have devices to measure energy in its purest form. You know, it always has to be doing something, like have something extra. We have to segregate it, or we have to have it at a frequency. We have to move electrons. Again, we just can't see the little stuff moving. We can only see when kind of big stuff starts to move. So until the force moves in electrons rather dramatically, we can't know it exists. And that's, you can say that, well, we can't see any of these little things coming off of this. Well, so what? We can deduce their existence by understanding that this explanation explains the motion of the electrons, and it explains the motion of the protons, it explains why the magnets turn, it explains why there's an inverse square law, it explains all the observed phenomenon, and it does it without resorting to bent ether and virtual photon. And even when they say virtual photon, they're just saying, well, we know it's some kind of thing radiating. They don't explain why it's positive and negative. They don't explain why it causes repulsion and attraction. So they don't even have the basic function. They have absolutely no explanation. They just say the same thing causes repulsion and the same thing causes attraction. When you can understand, no, they've got to be different things. And I'm just saying, there's just no reason, there's no facts that indicate this is wrong. And you're just saying bent space and virtual photon is somehow a more enlightening explanation, when this explains it and gives you a physical mechanism causing it that's perfectly consistent. Again, we know the speed of these little bits, these virtual photons, we know their speed is the same as the speed of light. We know this already. We know that gravity is doing the same thing. So all this magnet's doing is filtering gravity, essentially. Gravity goes in, gravity comes out segregated. If you're not a magnet, you don't notice, you just notice gravity. If you're a magnet, you can tell the gravity's been segregated, it's been changed, it's been, you know, separated, color separated. And now, if you're a magnet, you can detect a much different kind of gravity that now can be much stronger because it's segregated. All the blowing energy is going one way, and all the sucking energy, so to speak, is going the other way. And you can understand that if you did that, if you mix the two, you'll go nowhere. But if I make all the stuff going this way and all the stuff going that way, if I separate those two, there's no more yin and yang. I separate yin from yang. You can understand the yang is going to be very strong and the yin will be very strong. If I take the two conflicting flavors, the two bitter, sweet, or whatever, and I separate all bitter and all sweet, you'll notice the difference. It will magnify the flavor effect. Whatever there's lots of analogies. But you know, that's again, I knew as a kid there had to be a better answer, and I kind of knew it's probably going to be something really simple. And it is. Yeah. You know, it turns out that these wacky stories, you just don't need them. This simple mechanism explains everything that happens in the universe. Everything. All right. So that's all I can do. I mean, all I can do is present you a reasonable argument. If you're impervious to reason, then yeah, I guess I'm out of luck. And such. So, till the next time. And such.